All right, Jim, the floor is yours. Tell us more about declarative Python monitoring apps.
All right. Well, I can't be as polished or well prepared, but hopefully I'll be more grubby and down in the weeds to compensate.
No, I'm sure it'll be
with questions.
Okay, go for it. Yeah, there's feel free to break in at any moment. I'll start out with some slides, but then I'll be diving into demos in random order or whatever I think of. So, and then whenever I'm tired, I'll stop. So basically just break in at any point. Don't worry about it. This is all fresh, brand new material that is only sort of half formed in my mind. I'd love to hear things that are unclear. I consider this a relatively small and friendly group, and before we make a bigger splash in the big world stage. So anyway, I work for Anaconda. I've been at Anaconda for 6 years, and I run more or less a research group there. I used to be a professor, and I pretty much reconstituted my research group there, and we maintain a bunch of software with one hat on, and then we deal with Anaconda's clients with the other hand and listen to their problems. And then we put our other hat and we write software. And we go back and forth between clients and writing software, hopefully to write software that people care about. That's what we get up to. And in the course of that work, we just created a new package called Lumen. That was created by Philip Rudiger as part of one of the contracts with one client, but then now it's being funded by another client. So it's already got two sources of income. And I run the HoloViz team. The HoloViz team, we came up with this name because we realized we generated a lot of packages and it was hard to refer to them by listing them. So we came up with this name. HoloViz is basically everything my group does. And if you go to holoviz.org, you'll see all about all of our different packages. And this particular package is one that builds on everything we've ever done. But everything we've ever done is in Python, but it allows you to kind of harness that power without using Python. And the way it can do that is that the entire time we've been working with Python, in fact, the entire time I've been doing anything with Python since 2003, we've been trying to do Python in a declarative style, not an imperative, but you just, when you're using the software, you say what you want rather than say how to do what you want. And you'll see what that means here. And the result is that it was actually pretty easy to write it to take our tools and make them able to be done by a simple text file that's not about Python programming. You're just listing what you want the software to do. And as soon as you can do that, then what can you do? Well, you can make a GUI. And so what we've done is, and we have a GUI, I don't have anything I can show you, but essentially what we've done is build kind of modern point-and-click dashboard and plotting tools like Tableau or Power BI or Superset. But we built it all on a Python-backed framework. And so why would you do that? You already have such things. There are already tools like that. But here, this has come about because we keep dealing with different government agencies, different academic researchers who are running large projects in different companies. And in all of them, there are lots of people with lots of different skill sets. There's some super diehard Python people, and those are the ones we talk to directly. But right next to them, there are people who play with Python and do a little bit. And right next to them, there are people who don't know any Python, they use Excel. And right next to them, they consider Excel to be too weird and crazy. They'll just use Word and so on. And so all of these people have a role to play in an organization or a big research project or a big project of any sort. And we're trying to empower all of them to communicate with each other, to share approaches, to share tools, and not have these sort of chasms in between the different groups, where if you reach the limit of one tool, you have to throw it over to the next group, and they have to completely re-implement it with a totally different tool. So if you're playing around with Power BI and you get some great looking dashboard, but you can't do your custom plot, well, you give up and you ask your Python guy to do it. And your Python guy can do it, but he has to start from zero. So what we want to avoid is that, and we're really thinking about the situation of the large groups of people we're working with and make everybody be able to contribute, everybody be able to share, and everybody be able to use the power and customizability of Python without always having to write a bunch of Python. So you write it when you need to be custom, and then otherwise you just refer to it. So probably that doesn't make any sense yet, but I'll dive in and hopefully make it make sense. So here's a simple example, and before I do anything else, I'll actually show how this works. So here's such a text file. This is actually one file, but I had to paste it sideways. So just imagine the bottom part taped onto the other part. So this is 36, I don't know, 30 lines, something like that. And what this file does is specify this dashboard whose screenshot is up here. And then we'll switch to the demo portion, which is basically everything else. And then, so this file here is sufficient to specify this dashboard. And in this dashboard, you'll see, but you can download the data file. You can select subsets of the data, and it'll update the plot. You can zoom and pan and so on. And the way it's done is you title it. Then you have to say where you define these three different things. First, where's your data from? And then that's a huge topic. And then of your data sources, which sort of tables or chunks of data do you want to pull out of all those data sources? And you're going to name those. In this case, we named one penguins, and it's pulled out of this CSV file. And at this level, you can now take your data and either filter it, either just throw away some of you don't want, or put a widget up there to filter it. In this case, we specified we wanted a widget to filter it by species. So you'll see that there's a widget by species. Yes, somebody asked, is this the iris data set but with penguins? And it is completely the replacement of iris with penguins, because iris came from a eugenics-obsessed proto-Nazi, and the penguins did not. The person who put penguins together is a perfectly wonderful person. So we're going to use penguins, not iris. But if you're familiar with iris, this is just basically the iris data set. So here we're specifying that we want essentially the iris or the penguins data set, and then we're going to say that we want to be able to filter it by species. And that'll set up our data sources that we can work with. It's called targets. We probably ought to rename it, but it's that's just based on the source. The source is something external, and then it comes in, and the target is then something you can view. So a view here, we put up one view here. There are lots of types of views. You can have tabular views. This is the plot. It's a plot from a program, hvPlot. This can be anything supported by the panel library that I'll get to, and that means matplotlib, bokeh, plotly, all sorts of stuff. Anything, just about anything. And then the rest are all parameters for, first you say what type of plot it is, sort of the engine of it. Then you say what data it's referring to, in this case, penguins. And then the rest are all options that are passed to whatever plotting type you have. In this case, the plotting type accepts these arguments to make a scatter plot of this column versus this column, colored by this column, and then some other options. So let's see it actually work and go from there. Unfortunately, I usually have two monitors, so I put one on my code on one and my dashboard on the other, and it works really well. Right now they're crammed onto one page, but that's what we've got. So here we've got the data set, the description right here. And this is just the same thing you just saw. And then all we're going to do is do Lumen serve, and we'll use the very nice auto reload function, which I'll demonstrate, and then show. And all that does is make it pop on my local browser. Now, if I were running this in the cloud, I wouldn't use show because it doesn't know anything about my local browser. I would have to set up a tunnel or publish it on the web and then go visit it. But here I'm just running it locally, so I use this very handy show option.
Hey, Jim.
Yes.
Is there any way we can make that font size a little bit bigger?
Which one? In this menu?
I'm not sure. I assume that one, Sherry, was that the one you wanted to see?
The text file?
Yeah, sorry, we had a request in the chat.
Sure. There's a tension between everything on in the screen, and
she says everything if possible, please.
Everything. You have to get a bigger monitor for everything to be big, so that's an impossibility, but I will try to make the text bigger, and in this case, I think I can make the text bigger here. It's going to make the reason it was small is that I'm trying to cram this entire dashboard into one corner of my screen. So, but the text is big now. I just apologize. It looks ugly. If I take this same thing and I view it full screen, you'll see that it looks normal. This is what it's meant to look like. But let's get out of the full screen and actually be able to look at it. Okay, so hopefully that, so what I did there is I typed Lumen serve. Now Lumen is built on Panel. We'll get to all that. Panel's built on Bokeh. Bokeh has a Bokeh server. That's a web server. So what this is saying is start up a web server using this specification file for the web server and tell it to auto reload and so on. And so it loads this web server and it opens my web page. And then since my browser is pointing to it, it's able to show you the contents of this web page. And then you have an interactive app. You can hover, you could select some subset of it. Not that you can do anything. This is the simplest possible example, just about, but you can do some stuff. You can select, this is pre-filtering. This is filtering at the data level. So it's saying before the plotting program sees anything, filter this data. And we define that here by saying filter by species. And we'll add new filters in just a minute, but there's currently a filter by species. And so as long as you've got multiple filters, then it can color by the multiple values of species, then it'll color by the species here. These are all species of penguin for those who are not penguin experts.
Can you show us the data set initially so people
yes,
will like on? Okay.
Yeah, that's my next step, in fact, because I need that because I don't remember any of the other names of the column. So I do remember that for the iris data set, but those years of study of that are now useless. Okay, so let's add here, this is showing the columns of this data set. And so let's add another filter. Let's also make it be a widget because that's the only one I know how to do. Phil wrote this, I did not. So, okay, so now let's add a widget for text. That doesn't sound right at all, but okay, here we go. So there is a sex column in here, which is the second to last one. You can see it's male, female, and sometimes it's missing. When it's missing, it shows up as nan. And then here's the resulting dashboard. You saw that it auto reloaded just because I saved it. It's sitting there watching and it relaunches every time I save a file. So now if I separate out, you can look at the male penguins location versus the female, and it looks like for their bill depth and their bill length, it looks like the females are smaller than the males. So that's common to many species, but certainly appears to be true of penguins. So we can use that to make this scientific discovery that male penguins have bigger bills than female penguins. Discovery happened right there. I've never in fact done that. So what else can we do here? We can take something that for a year, that's probably not relevant. That doesn't matter to the penguin. So let's take a floating point value. So all I'm doing here is I'm editing a text file in a text editor. My text editor of choice, of course, is Emacs, but you would just use whatever your favorite editor is. And okay, so it looks like I now have a filter by body mass, and it's figured out that the body mass range goes from 2,700 grams, I guess. Yeah, it's in grams. So 2,700 grams, that doesn't sound like a lot, but okay. Penguins are small. And then you can filter by body mass. That's just because I decided to be able to filter by body mass. I declared I would like to be able to filter by body mass, and then Lumen does the rest of the work to create a panel app. If you look at the panel website, panel.holoviz.org, you'll see lots of examples. These are all apps that look like what you're seeing, but they're written in Python. A human being thought, I need to write an app about glaciers, and they wrote an app about glaciers in Python. Whereas with what I'm showing you here, a human being thought, I need to write a text file, and they wrote a text file, and now they have an app about penguins. So it's using all the same tools. It's building on the same HoloViz stack as everything else we do. But now we are able to do it from at a fully declarative way. But in our group, actually, we have this this policy called shortcuts, but not dead ends. Whenever we build an easy way to do something, we also want to make sure that is not a dead end. In this case, what if this functionality that's describable by this text file doesn't do what you want. So normally the answer is you buy a different piece of software. The answer here is you can create any of these things yourself. You can write your own filter. It's just a little Python function, a certain type of class. You can make your own source. You can make your own view. It doesn't matter. All of these things that we're seeing here are replaceable with your custom item, and you just put it in the same directory and you put it in a Python file, and then it'll load that. I wanted to put together an example of that, but I did not. But just trust me. Everything here behind it is just Python. It's just write your own thing if it doesn't do what you want. I don't care. And that's how it maps onto a big research group or a big group that's doing something in a company, which is you've got your super high-powered Python data scientist. They write a new analysis thing, a new transform. They put it in there. It does temperature-based anomaly detection. Great. You just say here, temperature-based anomaly detection, and it'll use that component. And the person next to you can use your code without them knowing Python. And so you can just focus on always doing something novel and new and not redoing the same thing all the time.
Can it go the other way around? Meaning take the text file and create the panel code for you? Like generate?
I demanded that of Philip today, and he says, yes, you can. And it's at the end of the talk where I just mentioned how to do that. But I said, that sounds too hard. We need to make that better. But yeah, exactly. We should take this. I should be able to take this and then go into a notebook and then use bits of it here, add this bit here, and add completely custom alongside this. And you can, but it's not documented, and it wasn't part of the original design. In fact, the original design was insanely different from this. Our whole point was we're dealing with clients who've developed dozens of panel apps, because it's super easy to write a Python panel app. And now they have to figure out how do we monitor them. And what we wanted to be able to do is write a simple text file where you could, each panel app is actually a REST API nowadays. And so you can actually ping the REST API, hey, how are you doing? Has anybody used you recently? Is your health status okay? Are you having any errors? And so we wanted to make a monitoring app that could monitor all of our panel apps or all of the customers' panel apps. And so that's why we wrote this thing in the first place. But you'll notice the title of my talk, you guys said it was monitoring apps. I took that word out because actually it does all apps. Because all apps are monitoring in some way. They're either monitoring the contents of a data file or monitoring a server or monitoring something. That's why you make an app, is because you're trying to reveal something to a human being. So,
I have more questions. I'll save them to the end. This is great.
Okay. Yeah, as you wish. All right, so let me go back to the slide to see what I was supposed to say. Oh yeah, I actually wanted to show a little bit about how it does its magic so that you can tell. Now it's concrete, right? You can see you write a text file, you get an app. Now, what is the universe of things it can do right now without having to write custom files, custom components? Well, just think of these three different stages. You need data to come in. We support intake. That's another Anaconda project. Intake is a data catalog and a data access solution that basically says, I don't care how the data was, just give me a pandas data frame. And it can handle a pandas data frame on S3, it can handle a pandas data frame on HTTP, a pandas data frame locally as CSV, locally as Parquet. It doesn't matter. All these things end up as a pandas data frame by the time it leaves intake, and we get a pandas data frame. So we don't have to worry about any of that. So Lumen doesn't know about all these data sources. It doesn't care. It just knows you can write an intake specification, which is also YAML, and you do that in the same YAML file, and it passes that to intake, and it gets a pandas data frame or a Dask data frame back. Either one, it works with both. And the only thing that we've done specially is support for REST APIs, because there's a very dynamic intake was meant to wrap around data files. We would like to kind of fold this into intake and never have to think about it again and separate the concerns. But for the moment, intake handles big collections of data files, and separately we handle live sort of querying of a server. So far, so good?
That's good.
Okay, so now you've got a pandas and Dask data frame. Now you can go to town on it, and then you can either just use it, in which case you don't have any filter or transform steps, but very often you'll want to, very often the data that you started with is not the data as you want to see it. And you just have, here's where you do your magic. Here you can specify all sorts of filters, like you can In text, you can specify many of the common arithmetic operations, like take this column, subtract it from this column, normalize by this column, all sorts of things like that. And that's just a bucket of operations that will only grow. There's lots of things there. They're super easy to write. They're very simple and very stupid. They just do something, and anytime you've come up against something that isn't there, you just throw it in there, and now it's there. But then transforms could be anything. Like literally, transform could be machine learning based, or it could be send it out to people and wait till they send you it back by email. Whatever. It can be any literally, you have all of Python at your disposal. You just put a little Python code in that directory, and it does any transform you could possibly imagine. So far, so good. Now you've got something you're ready to look at, or show, or reveal. All right, and then you have a panel to actually view it. Now, panel is also from Anaconda, but panel is not. Anaconda created the bokeh library for Viz. But panel is not in any way restricted to bokeh. Panel uses some technologies from bokeh, but panel will very happily display, I don't even know what this one is. It'll display Plotly, Matplotlib, Altair, HoloViews, that's our own project, bokeh and whatever that is. And perspective, that's a nice little way to, where the plot is not a dead end, you can really just show your whole data set and play it around, and in the browser you see which columns you want to show. So perspective is like, just give me the pandas data frame in the browser, and I'll choose what I want to see at the final end. So that's pretty much like abandoning the whole job of writing a dashboard, which may be what you want to do. Okay, and then you've got either a table or a collection of visualizations, and a bunch of widgets. So you have a dashboard. Okay. So when we're designing this thing, in fact, Philip and I just go back and forth, and the other members of the HoloViz team, each of us tries to out-generalize the other. And we say, okay, we can solve this problem. And somebody else says, oh yeah, we can solve that problem. Much bigger, twice as big, 3 times as big, with only a tiny bit more work. And we go, and then this is what we ended up with. For one thing, we can easily make distributed data frames just work out of the box. That means it doesn't take any extra work to do distributed computing with this system, because of just because of what we're building on. We've always been using Dask, which is another Anaconda project originally. Now it's co-owned by about 5 different organizations. It does include security, basic security, which we initially did not put in. We just said, oh, you'll put it behind some firewall, but enough people whined about it that now you can make an authenticated app. And then the key thing is that everything is extensible. So the rest, let's just show you. Well, any questions? Let me stop now. And then when we're done with questions, or if there aren't any, let's just show more complex examples as we get into them.
Yeah, I'll ask my questions now. James already knows this. I've been bothering his team for quite a lot for doing all sorts of reproducible, like papers that are generated or presentations that are static. They have the capabilities of doing so. Can Lumen do the static thing and not the web API? Can you just ask it to save me a file as HTML and that's it?
In principle, yes, because everything that's built on can do that. But that's part of the same question as going back to Python and working with the rest of that, which is to get things out of it that it's not a standalone Python. But what it really wants to do is make a full-featured, standalone Python-backed web server. That's what it's all designed to do. And what we need to do is unpack that a bit and make it easier to pull out components and then use them in other cases, or to pull something out of its template and generate just raw HTML and spit that out. And the answer is yes, that it can do it in certain cases, but we have not studied it, we have not optimized it, and we have not documented it.
So currently not, but you might explore it in the future.
Exactly.
No, that's a good answer, but you have the basic capabilities if this will be needed in the future.
We have a great starting point, which is that you have a declarative specification that immediately has no code in it. There is no Python. So in principle, you could translate that all down into JavaScript. All we have to do is more work. right now we have a bunch of Python code that translates some things all the way down into JavaScript, and other things call back to Python to get their work done. You'll see some of those in a minute. But as long as you aren't using those things that call back to Python, you don't need Python anymore. It's all JavaScript, HTML, CSS. And so we could identify certain pathways where we say, oh, well, we've been lazy, and we call back to Python, and then we go back there. We don't have to. We could just go ahead and write that thing in JavaScript, and it would never need Python for that component and this component. And there are certain chunks that we could identify and make the final result be completely weaned off of Python. So you can easily just send it by email or just put it on any web server. We haven't done that work.
So what I see when you show me this, I'm saying up until now you were able, in the future, before you were created, before HoloViz, people had to write all those interactive JavaScript pages. They have to have web development with all sorts of capabilities in JavaScript and all sorts of libraries, and not even all web developers can do it. After you translated it to Python with Panel and HoloViz and all your apps, people can now generate those using only Python. But now you're getting it to the level that you actually can write some text file in some funny, simple language that will generate those things for you that will be static and you can send by email. And then like disconnect from the internet and it'll still work interactively. This is what I'm seeing new capabilities in the this is great.
Yeah, that is true. Okay, yeah, well, we'll have lots of things to unpack about things that, just like I said, we haven't realized just how powerful this is as we've gone along, and we keep retooling it, and that is one way that we'll have to retool it, I think.
There's business opportunities galore here, but more than this, I'll be bothering you quite a bit.
Excellent. All right, well, let me actually show you that was the simplest example of what it does. Let's actually show some more powerful examples.
Actually, before we hop to the more examples,
sure.
We do have a question from the chat. So CG would like to know if there is Django integration.
Panel is well set up for Django integration, and I have no idea if anyone has tested that with Lumen. If it does not work right now, it can work. It is not going to be very hard because everything that's built on is we were paid by a government agency to make it work with Django. So we do have Django support for Panel, and we might need to do some work for Lumen, and I just haven't thought about it.
Excellent. Thank you so much for that answer.
Okay. All right. Let's look at another dashboard. This one is a little longer. It is 75 lines long. And first, let's just show the dashboard. That was full screen. Okay, so this particular dashboard is showing New York City taxi data. In fact, some of it's off the screen at the moment. So you can make the apps fully responsive, but we haven't done the work to really think about what all of the, and so it adapts fully to each size of web browser and device. And so we have a good template that does a pretty good job out of the box, and then we need to do more work about specifying minimum sizes, maximum sizes. So don't complain about that. We know we need to do that. So that's why things don't just immediately work beautifully. But in this case, I reduced the magnification a little so that everything fits on the screen. It already has things like this where you can shrink off parts of the user interface that you're not using. In this case, we don't need that. So, all right. So what this is showing is 10 million trips of New York City taxi data, this on the left is pickup data. On the right is drop-off data. This particular app looks like it is being extremely slow. What it's doing is updating about 1 million times at the moment, when it should have very quickly updated. Hopefully it'll wake up. It's been sitting here running on my machine, and my guess is that it is slowly coming back into existence. Anyway, what it's showing here is pickup data on the left and drop-off data on the right. Darker colors indicate more pickups or drop-offs in a certain area. I'm just going to reload. The whole page doesn't take that long to... well, it's actually kind of fun. Here, actually, no, I'm going to use this because this is showing you that it's rasterizing the data. This is using a program called Datashader. another HoloViz tool from Anaconda, and that tool takes data that might be large collections of many row point data, and it rasterizes it by counting, essentially doing a 2D histogram of the viewport. So every pixel you can see, it counts how many data points fall into that pixel, and then it colors that pixel dark blue if there are lots of data points, and light blue if there are fewer data points. And as you can see here, I actually zoomed in, and it took a long time to catch up here. I have no idea why, but what it's doing now is now it's got now each pixel is actually the size of my viewport, so you can see the full set of data available. And then this one is not even running over here, so ignore that one. But this, now that you have the data here, the fact that there are 10 million data points don't matter, because it's been rendered down into essentially like a PNG. So that's why we can display it in a web browser, even though it's many more data points than you ought to by right be able to display in the web browser. All right, and so here now we can automatically select parts of the, we can filter by the various data sets against each other, sorry, various views against each other. You'll see down here there are lots of histograms. This whole thing is not working, so let me just get out of here. Oh, now it is. Being very slow, I'm guessing it's spending all my time processing meet.google.com instead of my app. In any case, here I selected this histogram, and what it did here is filter out of all of the 10 million data points, it's only finding the ones that were for high fair amounts, and so on. So we have interactive cross-linking, which is currently extraordinarily slow between all of these data points. So that's pretty much all I wanted to show that the app does. And let's actually show how it works.
Is the map like OpenStreetMap, or what's using for the
well, let's see. It says it in the file, so I believe it's OpenStreetMap. So no, it's Wikipedia, which might be derived from the OpenStreetMap data sets. Okay. The best thing that it is. Okay, so let's just go through the code and see what's in this, what we're seeing here. All right, so we titled this Taxi Trips, and that's why it shows up here. And we say, where are we getting our data? It's from intake, like mostly that's where we get our data. And the data is in Parquet format. It's obtained from this URL. And it's cached locally because this is a pretty long data set. It would take minutes to download. So we tell it explicitly cache that thing. And then we define a couple of targets here. We're trying to say that we've got, actually no, here we're defining views. So the view is, we're going to have a view that is the pickup locations. We're missing a title here. I don't remember the syntax for title, because you'll notice that it doesn't say drop-off sources pickup, so probably we ought to be declaring that, but I don't remember the syntax. But here we have a pickup X, and it says that in the background we're going to have some tiles that are Wikipedia in this case, but I can change that to other types if I remember their names. And then here's where it calls Datashader. It's saying to rasterize it. Datashader is rasterizing the data. If I were to change that to false, you saw how slow that was for whatever reason, it would be about 1 million times slower. It would probably just crash the browser, so I'm not going to do that. And then I'm turning off color bars, and I'm defining what's called a selection group. That means that this plot is going to be part of a notion of selecting that's called taxi. And I declare that for each one of these. This one's for taxi group, this one's taxi, and this one's taxi. And that way when I select on any one of the plots, it selects on all of them. This is called linked selections or linked brushing, and it allows you to find a feature in one view of your data and see it in all of the others. So if this were working, I would be selecting the airport, and then I would say, oh, of the airport, what's the distribution of fares when you start at the airport? Or where do you go? Having started at the airport, where do you end up going? Or how many passengers you have? And so you can filter it by that, and then say, of the ones that started the airport and have a very low fare, where are they going? And so on. So if it were working well, I would show that. Okay, and see the drop-off is exactly the same. And then there's a kind of histogram, it says, and there's histogram by trip distance. I decided on well, Philip decided. Sorry, I don't want to take credit for his work. Philip wrote this one. In fact, he wrote all of those except for my own modifications to the simple one. This is really his project. But he's in Germany, so he's not going to be presenting in Austin Python Meetup, is he? All right, so I said hvPlot histogram, and then another hvPlot histogram, and another one. And at the end, some options. Here's the reason it has this layout. The layout is saying that normally it'd just be a column of everything or a row of everything. Here it can be the first 2 items followed by the next 3 items. So you can specify whatever layout you want. And individually to specify their own heights. So you get something like this. And so here we're declaratively turning on the power of Datashader by saying rasterize equal true. Now that involves a ton of other libraries and all this processing code and all these packages that Ching helps make sure are in the right place at the right time. All these different Python libraries get invoked just because I turned rasterize equal true. But it's declarative. I'm just saying I would like this thing to be rasterized, and it's doing the work necessary to rasterize it. Any questions on this particular example?
Yeah, the layout thing, it's like it's numbered according to each element that you put in, like the first one is 0, the other one's 1, and the rest is like
they're in order of,
columns?
they're in order of this list, and there's a feature request to be able to put a name on each one and then refer to it by name. That would be a lot better. Sorry, I filed that feature request. It has not been dealt with yet.
No, I got it. This is great. It's much better than it was before. Since in Param you actually had to do rows and columns before.
That's right. And here, that takes code to write row of blank and blank and a column of blank and blank. That's code. Here it's just a dictionary or a nested list. All right. So, all right, that's the taxi. What's the next one? Okay, the next one is bikes. These are all, by the way, examples on the Lumen website homepage. So there's no special stuff I'm doing here. I'm just taking you through what's on the homepage. But it's not trivial. The only thing that's not trivial about it is the environment, as again Ching knows. When you invoke rasterize, you have to have all the stuff installed that rasterize requires. And here you have to have GeoViews installed, because GeoViews is taking all of these locations in London and projecting them onto they're stored in lat long. When they're being plotted, they have to be plotted in Web Mercator format. You have to do a projection. GeoViews handles all of that. So if you don't have GeoViews installed, you try to run this app and it'll say, hey, I don't know how to do a projection. And so that's going to be something we're struggling with, which is how to nicely capture the fact that your simple declarative text file depends on things to be in the environment. And we can easily just put in a conduit environment in the text file and say, hey, this is our environment. But it's not like we want to necessarily say we'll only run in that environment. So we're struggling with that and trying to figure out what to do because our apps do depend on having things available in the environment. Maybe it could just be a little spec saying in the text file, these things should be in an environment, and it'll quit at the beginning if they're not.
But you said, anyway. You said before that you can redefine each element. So you can say the element itself contains the environment, no?
None of the elements involved here include an environment. We could make one, but yeah. They don't really. So
that's the idea, just define new elements.
That would hurt my head, but maybe. I'll think about it. All right, so first let's see what this app does. It looks like I must have hit refresh accidentally, but that's fine. Okay, so this is, again, the little hamburger menu. You can turn this off. It probably ought to start off because it doesn't actually do anything useful. There's no widgets. And in this case, it'll, these are all locations you can get a public bike in London. So there's a data set, a CSV file. It's got this structure. These are all the places you can get a bike. And at this moment, that was the number of bikes that were there. And so again, we have histograms. So in this case, I don't think it's showing you anything terribly new except for the table. So let's focus on that. So the bikes YAML. I'm just going to stop if I see anything highly unusual. Something I haven't discussed. Oh, here we're declaring what should be in this hover column. So when we hover over something, if I try to stop there and make my mouse not move, we're going to add one thing. We're going to add the common name to the hover column, and the common name turns out to be like the name of that area or the stop, or this little chunk of bikes is called this. And St. John's Wood Church is the example in this case. And so you already have the latitude and longitude just to be able to plot that point. And then I'm going to guess that it's colored by count. Actually, I should check. Is it colored by count? Color. Yeah, it's colored by count. Okay, so that's why we only had to add one thing to the hover, because a point automatically knows the lat and long, and we told it to color by the count. So those are automatically in the hover. We don't have to tell Lumen that, but we explicitly said also add the name of that stop. That make sense?
Yes.
Okay, so that's new. Then again, we're using the selection group, and so if I see that, I know that I should be able to do this filtering. So if I filter to that, it should update. Here it's saying if I filter the number of total docs, that has pulled out a subset of the available bytes. It doesn't look like it filtered the map, did it? Oh yeah, it did. Okay, I just took too big a chunk. So here, show me all the places that have, let's say, 50 bytes. Where can I find 50 bytes? Oh, okay. Apparently, you can find them in Stratford and City of London. All right, I don't know what's special about Stratford, but there are apparently very large bike stands there, and so on. So you can ask a question like that, and in the final app, answer it without having to go back even to the text file, let alone Python programming, to try to answer a question like that. Of course, given the talk before, you have to really think about the quality of your data. Like, how did they systematically underrepresent the large byte counting areas? Well, we just get you the data. We can't tell you if it means anything. All right. Okay, the table. So here's where we're specifying the table, and so we're trying to set up this table right here, and the table is showing the common name and the number of bytes. And we told it to suppress the latitude and longitude so that it's only showing the name and the bytes, the number of bytes. Okay, and then
we have a question that's come up in the chat here.
Sure.
So Patrick says that they were wondering whether you can say a few words around debugging, error reporting from the YAML files.
Yeah, let's cause an error. That's a good idea. This probably will not do anything. Let's see. Internal server error, that's not so good. What about times I? So there's some nice, there are nice cases where you get a beautiful little box on your screen here that shows a traceback. Now, I don't know what the conditions are. I requested that, and it has appeared there. I actually don't know how to invoke that. But as you can see, it's pretty easy to recover if you've done something bad. Like I said, that will screw it. Oh, there you go. I think the first thing I did, which was just not valid YAML, that we need to add a check for just completely, totally not valid YAML, because that looks like it errors before this bit that's capturing the error. Here it's saying that the height must be an integer, and 500 times I cannot be evaluated into an integer. And so it's just telling you what happened here. So here there's some nice, reassuring, meaningful statement of what went wrong. Whereas when I put just the total nonsense that was not a YAML spec, then we got nothing useful. So that's definitely something that we're just going to have to encounter over time. The more trouble we have, the more we'd say, oh, that's not a very helpful message. And so, of course, there are messages on the terminal as well. Mostly they're warnings, and many of them are pointless. Like this is just some sloppiness that we had somewhere. Here here we're setting the number of columns to 3 somewhere in the code, and it's being ignored because it's setting in place where it won't be paid, nobody will pay attention to it. We need to find that wherever it is.
Yeah, so for the people that don't want to deal with Python at all, it might be helpful to actually come up with just like a simpler message instead of showing the whole.
That's a good point. The error message can, like in this case, let me see. I think just the exception itself is sufficient. Parameter height must be an integer. You'd like to, here this is showing you the Python traceback. That's not the context you need. You need the YAML context. You'd like to see that in reference to that line of that YAML file in the context of your YAML file. So that'd be a great feature request. I'm going to forget by the end of the talk, but I totally agree. When it's being displayed in this form here, it ought to match the actual thing that's under control of the user, which is YAML, not Python.
Flow and file an issue. They respond to those. I know.
All right, I'll do it.
Somebody file an issue because I totally will forget that one. That's a great idea. Okay, and then the last. Okay, just 2 more. There's 2 more concepts. One is faceting. Let me try to explain faceting. I have not actually done it, so bear with me. So this is another one. Here it's got a description. I think that description ought to be showing up here somewhere, but it doesn't. But anyway, this is a bunch of data from various different models run under various conditions about assumptions about what I assume are carbon dioxide emissions. Well, just pollutant emissions in general, which might be carbon dioxide. And these are 3 scenarios ranging from not very much emitted to a lot emitted and something in the middle. And but then we have 3 different models for how the Earth might respond to those different emissions. And so how did we end up with 3 different plots here? What you should see, if this is faceting, what you should see is that there's nothing in the YAML file that says model PCM NCAR or model MyRock 3.2 or model ECHAM5. Instead, what you should see is facet on model. So I'm just assuming that because I have not even looked at this file. Let's see. Facet. There we go. That's what you should see there. It is faceting by the model, and we probably ought to. Oh, I can't pull the. I can't show you the data because this is actually a bunch of data. If you look at this, Intake lets you treat a collection of data as if it's part of a unified data set, which is one of its best features. I love it. And you can say, if you have a bunch of CSV files, in this case, they vary by, they have these things encoded in the file name about which model they are and which of these different emissions they are. And so each one of these plots here, that's a different CSV file, but you're able to refer to it as a big block and then treat that as a column in the data. In this case, the model is now a column in the data, which was just encoded in the file name. And so here we're saying, we're going to facet by file name, essentially, by this chunk of the file name. And every time you have a different file with a different chunk in this spot between precip and CSV, you're going to get a different plot here in your dashboard. I hope that makes sense because it's super important, and in fact is why we designed this entire system. So that you could write a text file that doesn't know what it is you're going to be displaying and can query some other server or some other file. So that's the whole point of our declarative approach, was that we were trying to make sure that we could write an app that makes a dashboard when you don't know what it is you're displaying, because one of the things you need to know is what is there to display. Such as if you're querying what are all of the running apps on my system, you don't know how many there are, you don't know what their names are, you just know how to find them. You have some way to find them, some server, some program you run that maybe runs PS and checks all the ones that have that and then finds all their process IDs and then whatever. You just have something that you're going to run that's going to tell you, and you can't lay it out as item 1, 2, and 3. You just have to be able to say facet on that value, whatever it is, give me a small multiple with each one of these, the same plot that I'm going to describe here, but now for each one. And so you'll look at the specification. This is going to tell you that it's got a hvPlot line plot of time versus precipitation by the model and emissions, and then you're going to facet that whole thing by model so that each one is only for one of the models. So that probably won't make too much sense, but hopefully the idea makes sense. You need to make dashboards to show a lot of things that you can't enumerate except at runtime.
Can you do very similar things that you're doing in HoloViews? Maybe I know that they're related to panel, but you can like put a plot on top of the other and stuff like that. Like you have those operations of multiplication and plus that you can actually put things on top of each other.
Yes, that's an overlay, and here it's kind of an overlay by default, which is these three things are overlaid on top of each other. But you can also explicitly overlay, and I do not know the syntax for that. For the taxi, this is an overlay as well, but that was an implicit overlay. You just said tiles, and it knows put tiles in the background.
And to explain to everyone else what overlay means, because you answered my question, but it's important that everyone knows that you're capable of it.
So a plot like this is just a set of map tiles. This is like a Google Maps, and it's basically taking images about 256 by 256 or so chunks and saying, wherever you are in the world, give me the chunks that overlap this viewport, and then show me that plot. And then you overlay some actual data on top, and that's what we have over here. This is the data on top that's being overlaid on the maps. And so each time you can see I've zoomed into the map, that's independent of the data that's there. And each time you'll see the map updated independently of the plot updating. And that's because this is an overlay of data on top of map. And you can overlay any number of things. Here it's doing it implicitly. I have not learned yet the mechanism for overlaying anything else.
Think about it as a stack of transparencies on top of each other. Each one is an overlay.
That's right, and the counterpart to it is a layout. This is a layout. This is what's called an n-dimensional layout, where there's an axis here, and the axis is that the model. This is the model axis going top to bottom. This is a layout, an n-dimensional layout. In here is 1. There's a one-dimensional layout going from top to bottom by value of model. So this is a layout, and then with each one it's an overlay. But by default you get a layout, and you'll have to do something special to make it an overlay. Okay, almost there, and I think we've built up to the thing that we were trying to do in the first place, which unfortunately is not running. I tried to start it and I didn't have permissions. What this thing is doing is, if you go to our examples.pyviz.org, this is all sorts of examples that we've made it with our tools. In fact, none of these are on there yet. They all ought to be on there. In fact, that's another to-do item. But here it's got a bunch of our examples, and if you were to visit any one of those examples, you could view a running version of it, and it'll show you a live demo. This is a running app that's running in the web on one of our servers in the cloud somewhere. And we've got something like 40 of these running. This is one. This one is running very well. Look, it works. But there are a bunch of them. And how do we know if any of them are going down at any moment? Is there a problem with some? So that's in fact, we told our client who wanted to model all of everything, we said, well, what we're going to do is we're going to solve our own problem, and then we'll see how much of it maps onto you. Our own problem is that we got all these dashboards, and we're trying to monitor all of them and see which ones are popular, which ones are running out of memory, which ones have we over-provisioned, which ones has nobody ever visited and we should just kill. And so that's this. This dashboard is actually monitoring like square limit. That's one of these things in here. That's one of the apps that we're monitoring. Square limit, it's right there. So in this monitor app, this is faceted by deployment. So square limited is a deployment. You just saw the attractors. There are 40 some odd deployments. So this is a faceted plot by deployment. And for each deployment, I want you to show you the memory it's currently using, how long it's been up. In fact, we restarted all of our deployments in the past day because our certificate runs out every 3 months, and it ran out today. So we restarted everything. So everything's been up for 9 hours. And this one, this has been up for 9 hours, and it's restarted not at all. It has, we don't have any visitor data for it yet. I think that things are being collected at certain intervals, and we don't have the data for that yet, so it's not showing what it is. Showing that it's not restarted. It's showing its recent history over the past well, since it's been up, looks like 9 hours, showing it used memory for a while and then it's gone back to 0. Nobody's visited this thing recently. And then you can look around, and then whatever down here, I don't even know what that is. It's iPod Lightning Talk. I don't know why that's deployed, but it's got an error in it because it's been restarted 76 times since in the past 9 hours. That's just some junk. We left that around to the server. We detected that it's there by this screenshot. If it were live, I could go kill it. But in fact, you can make it. You can add stuff in here, and you can make a button, and you put a Python thing, and you said kill it. I can make it be an active dashboard that does stuff, but at the moment it's just a screenshot, so I can't do that. And so on. So and then we have information like this is actually queried from the panel app itself that's running there. So the panel app has a REST API. We ask it, how long do people spend at this app on average? And how long does it take since when you first get a visitor to how long you return the result? Because we care about that. That's how long it took for them to see the dashboard appear. So we want to optimize. We want time to render to go down, session duration to go up. That's engagement. Visitors to go up. And so we monitor this dashboard and think about our problems. And we want anybody to be able to do the same thing based on a pretty simple dashboard that tells them a simple text file where they specify what they care about. Here we're specifying we want an indicator that has a dial that tells me the memory percentage. We want to have a dial with the CPU percentage. We want to have that's another dial. I don't know what any of that is. Anyway, we want others. Oh, sorry, that was a different section. Those are not the dials you're seeing here. There's another page. This is a multi-page app, by the way. We're looking at the details page. There's also 2 other pages that are totally different. That have the deployment overview is just a table of all the deployments where you can sort by which ones are using the most memory, which ones are using the least, and so on. In fact, that one's probably up. So the other tabs don't require the same permissions, so I can actually run those. But anyway, the other tabs are having totally different data, and I was just showing you there. I was showing you this one that has a bunch of dials. And then there's also this, which is everything sorted by uptime, and you'll see they're pretty much all the same uptime, which one's using the most memory, and so on. So that's done in this table. This table says the memory percent, CPU percent, and so on. So I get this table because there was this chunk in the spec, and then I get to the details page. And that's what I was showing you with this screenshot, which is I need a memory percent dial. I need an restarts indicator, which is a number. I need session info, which is a number, and a time series plot of CPU usage over timestamp. Okay. You can pretty much, if you look at one of these apps, you can think, oh, what would the YAML file look like? Oh, it's going to have memory. It's going to say memory, and it's going to say timestamp on the bottom, and so on. Then you can look there. But of course, that's my last point, which is that you have to know that and think about that and know the structure of this file. But this is all something that can be enumerated. We know what all the values for these things can be. We know what's been defined and what hasn't been. And so why don't we have an app for that? So that's what we've got now. We can just make an app. We know what goes on all those widgets. We know what once you've chosen hvPlot, we know what all of the other options are. We know all of it. And so, because it's all declarative all the way down, we have this whole declarative system. And so I don't have that to display. Only Philip can display that, to demo that. But there's the whole Lumen builder thing where, again, it's pluggable. You can have different ways of designing your view, your plot. One of those is perspective, which is already out of the box able to design a plot and let you pick which columns you want to see and whether you want scatter or line or whatever. And having done that, then you can link them all up and lay them out. So I won't show that, but that's where it's headed, and that reaches yet one more step away from Python to people who are comfortable with the interface. Also, it's a great way to learn because, as you've seen, I don't know what all of the possible things are here. I like to start with a big file because then I can at least delete because I don't know what all the possible options are. But I can actually guess by looking at the examples. there are only 4 examples on the Lumen website, so you're not going to be able to guess all of them.
So go back to the Lumen builder thing. You're not going to show it, you tell it, but is it like an app where you can actually place the things on the screen and play around with them, and then it creates the Lumen file for you?
Well, it consists of these components. You first select a data set, and that's basically a GUI for intake, and intake has a GUI. And so right now with one of our clients, they're not using intake, they're using a different system. And so we've done, that's pluggable. And so we're using their system, and we haven't really built up the intake system. But the intake system is also, is already pretty solid, so we can select that. And then we need to be able to select the tables from each data set. That's something Perspective provides. Then we set up filters and transforms. That's just a set of canned functionality you select from what's available using a panel widget. And then you declare your visualizations, again, Perspective, or we could do a different job. At the moment we're using Perspective. And then there's step 5, which is where you would like to be able to drag things around, drag and drop. And at the moment, no. At the moment, you can choose between some canned layouts, but we do have templates for panel apps that give you drag and drop layouts. That just where the final panel app is a drag and drop layout, where you see the panes here, you just drag them around and rearrange them if you like, and then you can query what is their state. And so we can easily imagine putting that in there so that you just dump it out and give us an ugly one. You let people rearrange it, and then you memorize where they were. We're not working on that. We're in low ambition for step 5 at the moment. But what you can do is just come up with anything ugly and then spit it out to step 6, and then you've got a YAML file. And then you just do whatever you want to fix whatever. It's going to be limited. It's never going to be exactly what you wanted. But if it isn't, just edit the YAML file. It'll take you 2 more minutes. Because at that point, it's already all in there. You don't have to imagine, oh, what is the syntax for it? It's there. So then you just edit it. Yep. So that's our idea behind Lumen Builder.
Well, because the way you show all of those steps is something that you said at the beginning. You said that each person does something else and deals with something else in the organization. Like some people deal with data, some people do the dashboard, like the spreadsheet thingy, and some people write the Python. So basically, you're separating by ability to do this YAML thing, and each one, the person doing something different, you eventually are able to integrate an entire team using.
That's the idea. In fact, we're working with clients who are doing exactly that. They are people who've never used Python. They're designing Lumen dashboards. They're hitting a wall, and they say, hey, data science team, how do I do this? And data science team is writing a custom module and giving it back to them, and they say, oh, okay. And they don't even know how this works. They just know it works. They just know that they had this need, and somebody who knows how to use Python, who just seems like a god to them, wrote some code. But to them, they have this menu of options, and they have an out. They have a Steam escape. They have a way to get out of their limited menu when they need to.
Oh my God. So this will change the landscape of things. That's for sure.
I'm trying to change the landscape. So we are, all right. So what do we have to do? This is a very young project. The first release was maybe a month or so ago. It still has very rough edges. Number one, you can't even reproduce those dashboards you see on the homepage. As soon as you do, you're going to find that your kind of environment doesn't have the package you need for it. And we haven't solved that. What we're planning to do right away is at least put up one environment that has everything in it, so that at least you can just use that. But we don't have any mapping between YAML file and environment yet, or a way to do that. Then we need to release our dashboard builder, which we have not done, or it's not even committed anywhere. Then we need to make the docs better and add a bunch of new filters, transforms, and views. And as soon as we do that, we have to make the docs better again. It doesn't have a logo. All of our logos have projects have a logo. Philip did not like the logo my daughter designed, which was very rude. So he'd rather have no logo. And then we get to some of the things we talked about before that you brought up, Jacob, which is how to take tasks and users and improve the flow of everything between everybody. As soon as you see something on the screen, you should be able to work with it in panel. As soon as you see something with hvPlot, you should be able to work with it in Lumen and vice versa. And that's going to take a lot of time. So that's last on the roadmap. It will never be done, but it's definitely a goal. We want to make it easy. we want to remove barriers between personae and tasks, and just make it easy to just focus on the thing you're trying to do right now and not have to redo all the stuff you didn't want to redo. Okay, and then it's easy to install, but what's missing here is all the other packages. You also need Datashader. You also need Dask for one of them. You need various other things, and it's not in this list. If you want to actually get started, though, if you're willing to encounter some pain now, lumen.holoviz.org is up. It's pretty light on documentation, but it has what you need to do what's shown. If you want to see, this is all built on HoloViz tools. There are lots of other HoloViz tools. I mentioned a few of them. If you want to pay us to make it do what you want, please do. But we're actually getting paid pretty well to do it, because we have a lot of people with a lot of goals, and they are willing to say, okay, this is our roadmap, this is what we're working on. We have a big roadmap for Lumen ahead of us. So it's likely that we're going to get to what you want. So you pretty much don't have to pay us for this particular one. It's well funded and just has a roadmap in place. Someday funding will drop off, and you'll probably want to pay us for that. You can certainly pay us for anything else. If your company wants something else from HoloViz, please do. And then this is all work from Philip Rudiger. It's his birthday, actually. So he's not here, and he's not in Austin anyway, so you get stuck with me. So, thank you for your attention.
All right, thank you so much. All right. Yeah, that was great. Yeah, thank you, Jim, and thank you, Hansov. Yeah, it's two great presentations today. So
Wow.
I'm gonna start the recording right now. So
Wait. Before you do, sorry, we have a couple of questions from Sherry earlier that I missed.
Okay, sorry. Yeah.
Hey, I'm looking at the list.
Yeah, so Jim, you were showing the like visualization applications monitor, and so I know that it was just like a screenshot of the thing. But is there any way to look at that and like see which ones were the popular plots that people were looking at?
Yes. In this case, we would have needed to put that data on here. This particular table doesn't have the right column, but in that, if the details page, if I have the authority to see what's on that page, there's a sort over here, down here, and so you could sort by session duration, for instance, or total visitors. That's off the list here. I think that's off the screen. So all you have to do is, it has to be sorted by something, all of these facets, and the facets are currently sorted by the memory usage, increasing memory usage, it looks like. So you would click on that and then select reverse, and then you'd be able to look at the most popular ones or the most whatever.
Awesome, thank you for that. I'm glad you brought up the memory sorting, because that was Sherry's next question. What kind of memory usage is being displayed? Is that cache memory, external memory?
This is memory. These are Kubernetes containers, and they have, this is the total memory of that particular container, and the total usage of that container as Kubernetes defines it. And so there are a lot of holes in that definition. This is very virtualized, so I can't be any more specific than that. You'd have to dive into Kubernetes, but what it does tell you, if you looked at the overview, these are kind of more real. These are about the underlying hardware that the entire thing is running on. And of that underlying hardware, we're using 23%. But that doesn't help you tell about particular apps. So you have to get these proxies that are per app. But that's in a virtual environment with lots of baggage around it. So it won't really tell you the bytes that are actually used on your source memory very exactly. So hopefully that makes sense. It's about Kubernetes, not about Lumen.
Awesome. Thank you so much for that answer. And thank you, Florin, for holding off on pausing the recording.
Yeah, no problem. Yeah, let me see. Here you go.
Jacob has one.
Yeah, Jacob has one for sure.
Actually, it can wait after the recording.
All right.
All right. So stopping the recording right now.